Good evening all. We'll wait for a couple of minutes for students to join and then we'll get started. Good evening. Maybe we'll wait another couple of minutes for a few more students to join and then we'll get started. In the meantime, if you have any queries that you want me to discuss, then we can discuss them. I assume that there are no questions. Okay, then we'll get started with this week's questions. So I have some questions here. So we'll quickly discuss them for this session. And as I mentioned, tomorrow we'll have one more session that is not essentially related to the course directly, but I'll go through some papers so that we can understand how these techniques are being used in real life. So the first question here is something very similar to the one that is already been discussed in the lecture videos, that is for a fin problem. So you have a heat transfer surface here, and then there is the fin is an extruded surface. So this is the theta b refers to the base temperature, so which is higher than the ambient. So this theta b is excess temperature, that is the temperature difference with respect to the ambient. Because of this higher temperature, heat flows away from the fin, and then this is the governing equation that is already provided. This is the base temperature difference, excess temperature, and m is a fin parameter given by this particular expression. Physics of the leaving the physics aside, so this is the profile that is expected for the theta variation with respect to x, or maybe let us say it is x by L, say if we non-dimensionalize this. So what are the input features here? So let's say I have what are the inputs that I need to consider to develop. So when I want to use a neural network, I want to fit a neural network for this particular function here. So this is the function I want to fit a neural network to. So what are the inputs that I would be using from the data that is given here? You need to know the base temperature theta b. You need to know the heat transfer coefficient. K is the thermal conductivity, D is the diameter of the fin, and you also need to know the length of the fin and the particular x at which you want to find the value of theta. So these are straightforward, but these are the inputs that you would be needing when you want to solve this differential equation. Now if you want to use a neural network like we discussed before, most often you have to normalize these features before actually feeding it to the neural network. So how do I normalize this? So why should I normalize it? We discussed this before. Do I have to normalize, or can I just feed the actual values? So before actually thinking of normalization, so let me ask few more questions, or let me give you a little more information. Theta b is essentially the difference between the temperature at this particular point and the ambient temperature, and this usually ranges, say, it can range from 0 to some, it could actually be negative as well, depending on what you are like whether you are cooling or heating. Say let's say it ranges from -50 to 50. H is the heat transfer coefficient, and let's say it ranges from let's say 1 to 10. K is thermal conductivity. Let's say we are using some metal and say it ranges from 200 to 500. D is some fin diameter, which can range from say few millimeters, say 2 to 10 millimeters. Length can range from 5 to 20 centimeter, and x is essentially depending on this particular length value. X by L can range between 0 and 1. If you see, each of these inputs have different scales at which they range. So now if I feed these directly into neural network, how will what would happen? Is the question clear? Yes, thanks. Yeah, so what do you think? So since each of them belongs to different ranges, what could happen is, it's like if I use them directly, the neural network, what would happen with the neural network if we use these ranges directly? Okay, let me give you a little more hint. Let us also for now fix that I will be using a particular kind of activation function. Let's say I will use a sigmoid activation function. okay, I forgot to mention one more thing here. So these are theta, and theta is the actual temperature, that this is the output that I want to find. That could also say range from -50 to 50. So I'm just giving some numbers here. So let's also assume that I'll be using a sigmoid activation, or let's say I'll use tan H activation. So if I am using tan H activation, what will happen? What will the output of tan H range from? So if you see the tan H function, what is the range of minimum and maximum value that tan H value can give you for a given value of for any value of x? Tan H gives values between -1 to 1. So if I use -1 to 1. So if I use a tan H activation function in any of my layer, the output of the layer will always be between -1 and 1. But I want to use this neural network as a regression model that will actually give me value of theta, which ranges from -50 to 50. So I think now you can appreciate the problem. So if I'm using a tan H activation that only gives ranges between -1 and 1, but I want to find something between -50 to 50, I cannot do that directly. I need to use some kind of scaling. So that is exactly what I'm calling normalizing here. So if I could normalize all these input features before actually feeding them to the neural network, then the output will also be correspondingly scaled between -1 to 1. Then I will rescale it back to get the actual value. So how do I scale these inputs now? Like you could do it in several ways. So maybe you can suggest one way. How can I do this normalization? Say if I use sigmoid activation, then it would be different. If I use sigmoid, then it will range from 0 to 1. So let's say I'll use sigmoid activation for now. So I want my output to be between 0 and 1. So how can I normalize the data before actually feeding to the neural network? In most of the engineering problems, you will be facing the same issue, but say if you are in fluids, then you always use the non-dimensional variables, which are kind of between 0 and 1, and you don't have to worry much about it. But in this particular problem, you have to come up with your own way of non-dimensionalizing them. One could be directly using min-max normalization or min-max scaling. So what is min-max scaling? So let's say I want to scale h. So I'll create new variable h prime is h minus minimum of whatever existing data set has by max minus min. If I do this, what will be the range of h prime? I'm just subtracting the minimum, like I'm just doing some transformation here. I'm translating it by minus a minimum of h and then doing a rescaling. So this will always be between this kind of scaling will ensure that your h prime will always lie between 0 and 1. This is straightforward. So if you do the same thing for all the variables, then all your variables input features will be between 0 and 1. So that way you will ensure that your inputs are between 0 and 1 and your output is also between 0 and 1. So you can use a normal neural network with sigmoid to do some scaling. This is one argument. The other argument that we discussed previously is on how your gradients can actually explode if you do not scale it. So if these values are high enough, then when you do the back propagation, the values will keep on increasing and then you might end up in exploding gradients. Then your whatever optimizer you are using may not converge at all. So that could be the other problem. So now let me ask one more question. So the analytical solution is given by this expression. Let's say theta equals to So this is the analytical solution that is provided, or even without seeing the analytical solution, if you happen to see this particular plot here, so what kind of decay is this? I mean to say, is it
exponential decay?
Yeah, so if it is an exponential decay, so you think can I use any better feature than directly using these linear variables? So if you have a function something like theta equals to, let's say something like, this is the actual solution, but let's go with your argument. Let's say we have an exponential decay function. So something like theta equals to theta naught times e power minus t beta, or something like this is something you have in your first order systems. So now if I want to use a neural network to predict this thing, so essentially theta is a neural network that takes in theta naught as your input, t as t, and tau as your input. So this is what I want to model it. So question now, first question is, can neural network approximate exponential function? What do you think? The argument can goes in the same way. So what will be the value of your exponential function, the range of your exponential function? So to answer questions like this, you start from there itself. So what will be the range of my exponential function? So if x belongs to sub certain values, then what will be my exponential of x belongs to? If this is within 0 to 1, then you do not have any issue, so your exponential will also be kind of bounded between some values, but usually if x is very high, then your exponential will not be bounded. So directly using exponential function is not a very good idea for when you want to model this kind of functions. So what other things could I do? Because if you remember, what are we doing in neural network? We are just using some linear combination plus some activation function. So can I transform it in some other way that could help me? Let's say if I use a log transform. So essentially if I take a logarithm of this, something like this, or let's take the original function itself. So if you happen to see this function cos h and sin h, this can actually, if you take logarithm of that, log theta is essentially log theta b plus log of cos hx is something, I don't know if you are aware, so that could actually be written something like this. Basically log cos hx can be written as so I'm just using that identity to write it in a slightly different way. So what am I trying to do here? So when I apply the log transform, then you can see that some of the variables can actually be written in a linear combination. So instead of, in addition to using these features, if I can also add new features, say something like log theta b as one feature, in addition to whatever I have here, if I add this as a new feature, and let's say I have ml as another feature, 1 minus x by l as another feature, instead of directly using x by l, I can use 1 minus x by l as a new feature. So this is what you call feature engineering. You need to come up with new features that will actually help your neural network so that you can use less number of neurons to train your model. The next obvious question is, how will I know which features to use? That is again dependent on your problem, and like for this particular problem, we know the governing equation and we know what the final solution looks like. At least for one particular scenario, we know that it depends on the values of ml and it depends on x by l. So I'll choose features in that particular way. But for your problem, you need to come up with your own features. Okay, now let me ask the question regarding the activation functions. So we have chosen either tan h or sigmoid function. So can I use a ReLU function here? Or maybe even before that, maybe I should ask one more question. So if I have two numbers, x1 and x2, can I use a neural network to actually predict the product of x1 and x2? So this is my input and this is the output that I want from my neural network. Can I train a neural network to do this?
Yes.
Yes, you could do it. So is there any specific requirement on the activation function, or can I use any activation function? Question is, first you told S that you could use a neural network, then comes the next question. So what should be the values of x1 and x2? Like I should actually scale this x1 and x2 in such a way that they are within the limits of say -1 to 1 or 0 to 1. It's like I did some normalization, and if these are within those limits, say if x1 and x2 belongs to 0, 1, I'm just giving, so let's say we use min-max normalization, so both x1, x2 are within this range, then the product will also lie within the same range. So you can use a neural network to do this particular approximation you can do. So once you do this approximation, so what kind of activation function will you use? Tan h, sigmoid, ReLU, whichever activation function you use?
Sigmoid.
Okay, for this particular range sigmoid, you will be using sigmoid activation, because I told it is between 0 and 1. Can I use ReLU?
No, sir.
No? Okay, why not?
Because minimum value will be 0.
Yeah, the minimum value is 0, right? Minimum is 0 and maximum is 1. So why can't I use ReLU?
You are multiplying two numbers, right?
Yes.
So those numbers can be any numbers, or
No.
there's some.
Basically, I normalize both of these inputs to be between 0 and 1. So x1 and x2 belongs to 0 and 1.
Okay. So then, ReLU is possible.
Then ReLU is possible. So the only difference will be in the architecture that you will be choosing. If you use sigmoid, then you might be needing one kind of architecture. If you use ReLU, you might be needing a different kind of architecture. So let's not go into the architecture. The question now is, let's say I want to, instead of using the feature x1 and x2, let's say I will use log x1 and log x2. And then I can use a normal, essentially what I have to do is, if I use a neural network, all it does is log x1 plus log x2. So basically the weights are chosen to be 1 and 1 and bias is chosen to be 0. So this is equivalent to log x1 x2. So I could also train this in a different fashion. So basically instead of using x1 and x2, x1 x2 like as my training data, I'll apply log to my training data and then train my model on the logarithm of the training data. Can I do this as well, right? So when you have something like a product, this could also be done. So do you see any problem in the second approach? Is the question clear? So instead of training on x1, x2, x1 times x2, I'm using a new training data which is logarithm of the training data, original one. So I just use log x1, log x2 as my input and log x1, x2 as my output.
So minimum value is 0, right? So x1 minimum value is 0.
Yes.
So log 0 is undefined.
Yes. So let's say what if I put something like this, some finite quantity, if I add some finite quantity over there.
Yes, it is okay.
Then it is okay.
Now we can use that.
Yeah, that could be the bias.
Bias.
Okay, so let me ask, okay, if I was using the same sigmoid before as my activation function in neural network, the output of the neural network will still be between 0 and 1, but the log value won't be between 0 and 1, right? See, whatever the value I have, once I pass it through sigmoid activation function, it can't be used, right? I hope
Okay.
yeah. So then sigmoid is out of question.
Okay.
So can I use ReLU there? Instead of, so sigmoid is out of question. So can I use ReLU then?
So you are again using the same normalized values, right?
I have normalized x1 and x2. I haven't normalized log x1 and
That's
log
what.
x2.
Yeah. Okay. Okay. I think. Uh, yeah, ReLU won't work because log 1 is 0.
Log 1 is 0. So
So
can you elaborate a little bit?
so any value. Uh, so any value. I think. So ReLU gives either 0 or and then a linear curve, right?
Yes, ReLU is something like this. So for what are negative values of x, it will be 0, and for all positive values, it will give you a
Yeah.
linear
Yeah.
value. This is ReLU.
Yeah. Okay. Uh, so we are using logs.
Yeah. So what is the range of these log values?
Log could be
x1, x2 belongs to 0 and 1. So
okay. Okay. And that too you are adding. So the maximum could be 2 and log 2.
sorry, the
Minimum could be
minimum could be,
Infinite
0.
to
yes,
The minimum could be the epsilon
minimum
whatever
could
you are adding.
be 0. Okay, you
Why
have added
you are adding another?
so you will have something close, some finite small number. So let's say ln epsilon is your minimum. The maximum it could be is
1.
1.
1 plus
No,
something.
log will be 1 when you
0,
have
0.
this. Yes. So the maximum it could have is 0. So do you think this particular range will be covered by ReLU function?
Okay.
No, no.
Okay.
Yeah. Okay. So now we understood the problem. So I can't use either sigmoid or ReLU. So the only way that this particular type of network will work is if I use a linear activation. Essentially, don't use any of the activation function. So just pass it directly. That is a scenario. It will work. So why are we discussing this? Coming back here. So here I have again some multiplication operations here. So once I have the value of m, I need to actually multiply m and l. Similarly, I have to multiply this particular quantity again with 1 minus xl. So I have a lot of multiplications that I need to model with my neural network. So the first thing I have to ensure is all of them are normalized to that particular range. So if you have normalized to 0, 1, you will be using a sigmoid activation function. So depending on your normalization, choose appropriate activation function. And then you can proceed with either, say if you use ReLU or sigmoid, any of the functions should actually work, should actually give you the final answer, as long as you don't do this particular transformation. So as long as you don't do this log transformation and use these as your input variables, a ReLU or sigmoid should actually give you an answer. So the second question is actually inspired from the one that is already discussed in your lecture video. So now we have is a particular space. Let's say you have your refrigerator and you want to model the air velocity and temperature inside the refrigerator. So I want to use a CNN in order to do this particular estimation. So the geometry of the model should be actually provided as to differentiate between what is the fluid and what is your boundaries. So that can be done in several ways. So one possible way is to use a binary map. By binary map is like you take your entire domain. So if you have your refrigerator something like this, and let's say you have some fruit or something inside. So what it does is everywhere in the outside it will mark the particular value as 1, and everywhere or the other way around, fluid is 1 and whatever is inside the solid is marked as 0. This could be one way, and you will feed this as input to your CNN so that your CNN can differentiate between what is fluid and what is your solid or what is your object. this is your binary map. So keeping this in view, which of the following are true? First one is it will be able to distinguish between various kinds of boundary conditions. What are the various kinds of boundary conditions that we can have? In most of the fluid problems, yeah, if you are from mechanical or fluid backgrounds, and maybe you can be able to answer this straightforward. So what are the different kinds of boundary conditions we'll be having? One is something like solid boundaries, or we usually call it, say, wall boundary condition, where you don't have no slip or something like that. And then you have, say, inlet, where you have your flow coming in, or say outlet. These are different kinds of boundary conditions that you can have. Depending on your heat transfer, again you will have different kinds of isothermal or whatever boundary conditions are there. So with this binary mapping, can I differentiate these different kinds of boundary conditions? So this is straightforward. It just tells me whether it is a fluid or a solid. That's the only boundary condition that it can help me to distinguish. It won't be able to tell me whether it is an inlet type of condition or outlet type. Say if I have an inlet here, so let's say air is coming from the top, so some cold air is coming from the top, I will not be able to identify that this, this particular kind of mapping will only tell me that at this particular arrows you have the value to be 1. That's the only thing it can tell me, but it won't be able to differentiate whether this one is different from the other one. This one is something that your model has to find out, and these ones here are something that you provide as input. That differentiation won't be provided by this kind of mapping. Second question, if you have already gone through the lecture video, so what is that particular representation they have used in the lecture video?
Sir, ask again.
So this is the binary to differentiate between fluid and solid. Now I am proposing a binary map. So in the lecture videos, they have proposed a different kind of scheme. What is the scheme they have used there? To model the geometry, like to basically give your geometry as input to your CNN model.
-1, something like that. -1, inside -1, outside +1.
Inside -1, outside +1, and exactly at the boundary you have 0.
Side function.
Yeah, so
Side
you,
function, sir.
yeah, that is called the sign distance function. So essentially what it does is it calculates the distance from the nearest boundary, and then once you have all the values inside the domain, then it will normalize to -1 and 1. So whenever you are inside it, it will give you -1, whenever you are outside it will give you +1, and exactly at the boundary it will give you 0. That is a sign distance function. So binary mapping will only give you 1 or 0. So this is a sign distance function is a continuous one. So you will have all range of values. Binary map is a discrete one. So let's say, okay, which of these two do you think is better in terms of representing your geometry? Okay, maybe before asking that question, how do you know one is better than other? What is the criteria that you need to establish? Is basically you need to identify your, you need to differentiate between fluid and the solid. So if I am using a binary map, what is it that I am trying to do is first, in any image what you do is you pixelate it, essentially you split it into some rows and columns, and then if you have an object here, you need to label each pixel as either 1 or 0. 1 is when that particular pixel has a fluid, and 0 when that particular pixel is a solid. So that is one way of doing it. So if you want to do that, for simple shapes, if you are using a rectangular kind of, this is the normal kind of pixels that we'll be using. So if you have a complicated geometry, I just draw a circle here, but if the geometry gets complicated, you will see problems here, something like this, where you have the boundary passing inside some pixel, you don't know which label to give for that particular pixel. So you have to decide, say you have to come up with another criteria to decide what to do for these kind of problems, where you have both fluid and solid domains. How will you label that particular pixel? So discrete mapping is something that will leave you with this ambiguous choices. But when you use this sign distance function, what it does is calculates the distance from the boundary to that particular whatever that pixel is there. So it will give you some value. Say if you have more percentage of fluid, then it will give you a value closer to 1. If it is more inside the solid, then it will give you a value close to -1. Or essentially, if it is on the other side, it will be somewhere between 0 and 1. If it is inside, it will be somewhere between -1 and 0. So when you have these continuous values, your model will also be able to appreciate that this point is close to the boundary, and for the particular mesh you have chosen, or for the particular image that you have chosen with the particular resolution, you are not 100% sure whether that is a fluid or a solid, and that it has both fluid and solid features. This additional information will be provided when you use the sign distance function. So if you have gone through the particular paper that has been discussed in the lecture video, you will observe that they have actually tested with both binary and sign distance function that particular model, and they observed that when compared to binary, using a sign distance function gave them approximately, this one gave 2 to 3%, sign distance function gave 2 to 3%, while the binary gave close to 50% error for the same neural network that they have trained. So is it clear that why the sign distance function is providing more information than binary? That is the whole point that I want you to appreciate from this particular question.
Yes, sir.
Yes, thank you.
So explained very well.
Yes. So the other two options I think are straightforward now. So the second option asks you, can result in discretization errors for complex geometries. That is true, that we have discussed just now. It won't be able to distinguish different kinds of boundary. It will only tell you whether it is a fluid or a solid. It can result in discretization errors because of this ambiguity. How about the last one? It requires lower resolution image than STF. By lower resolution, I mean this. If you mean a lower resolution, it means you are using bigger boxes to divide your domain. So essentially, if you have something like this, the same problem. So this is lower resolution compared to this one. So if your size of each particular unit increases, then your resolution will get reduced. So if I am using sign distance function and binary map, so which one of these two do you will require a high resolution or say lower resolution for the same kind of output? Is the question clear? Okay, let me put the question in the reverse way. So let's say I've decided on the neural architecture, like I've decided my architecture, what architecture I have to use, and then the only thing that I could change, like I just now told that for the same resolution I'm using sign distance function and binary mapping, then sign distance function is better. Now let's say I'm not using same resolution, I could actually change the resolution when I'm using binary mapping. So should I increase or decrease the resolution of binary mapping for the same level of output that I have with sign distance function, like for the same performance of my neural network? So let's say this has say 1000 by 1000 resolution. So for the same performance of the neural network, what should be the resolution of this binary map? Should it be greater than 1000 or less than 1000? If you use 1000, it is decreasing, that is for sure. So should I increase or decrease? I kind of told the answer, so it should be straightforward.
I have to increase.
Yeah, you have to increase. So when you increase the resolution, what would happen is the chances that the number of pixels that have this ambiguous choices will actually decrease when you increase your resolution. So that way even binary will also provide the same level of information as your sign distance function. So that is the main logic here. Okay, let's go to the next question. This is on pins, where you have physics informed neural networks. So how is a pin different from normal one? The main difference is essentially lies in your objective function. In a normal objective function, we will use say mean squared error or your binary cost entropy kind of objective functions. And then in pins, what you do in addition to those, for the particular problem that you have chosen, you also know the physics of it. So you have the PDE in your mind and use that PDE also in your objective function. So that will try to minimize both the PDE loss as well as your data loss. So which of the following are true for this particular kind of training mechanism? First one, it will reduce underfitting. So the two options are with respect to overfitting and underfitting. So what do you think pin is doing? So is it reducing underfitting or overfitting?
Overfitting, sir.
It will reduce overfitting. So essentially, without pin is essentially kind of a regularizer that you are adding to your objective function. So in addition to the normal objective function, you are adding this PDE loss. So this is a kind of regularization that will actually reduce your variance. So that is essentially saying you are reducing your overfitting. So what about the last two options? So if you are using pin, so will you require more training data? Now that I've told you that I am using a regularization, which means it is actually becoming tougher for the optimization problem to find an optimal solution. So which of the following is true? Will I require more training data so that I'll get an optimal solution, or it will require more time for the same set of data? Whenever you do regularization, it means you are adding more constraints.
I think fourth one, sir.
Okay. Any other, since you told you think, so any other opinions that you might think you might require more training data instead of time?
Actually, pin does not require any training data at all.
Okay, a very strong claim. And then, okay, any other opinions? So basically, that also boils down to the last one, saying that, okay, let us come to that point as well. Pin doesn't require any training data, so you don't actually need more training data. So two of you have kind of told the same answer. Okay, let me ask you this question. So if I provide training data to a pin, will it be helpful or will it actually decrease the performance of pin?
No idea.
Okay. So as I said, it's a kind of a regularizer. So even without any training data, you are expecting that pin to actually work. But if you have training data already in place, then you can actually use it to help your pin, right? The main objective of pin is to essentially help your model reduce the overfitting. It could also be used to train your, without any training data, you could also train it, but the only problem is the amount of time you require to train that might actually be little high compared to that with having a data. But you can do it. Okay, so this is something we discussed during the beginning of the class. So let's say I'm defining a new kind of layer here. So I'm giving it some name, log exponential or something. So this is the layer I am giving. So if x is my input, when I pass through this particular layer, this is the kind of transformation I'm expecting. So if I want to do backprop for this, so the layer equation is given. Let's say y equals to log exponential of, let's say I use the same thing. So for some particular input, I have this as my output. And if I define my error as, say, I will use mean square error. So let's use the same notation as used in the lecture video. So now if I want to do the backprop, how do I get the gradient term? This is straightforward chain rule. So maybe you can quickly do this and let me know. Hardly takes 1 minute or so. Maybe I'll wait for a minute so you can quickly tell me what is the value you have here. So let's do something like this so it will be easy. So if you do this second term, so this is essentially saying something like this. So what is it that you get here? This is straightforward differentiation, so I don't want to spend more time on this. The only point I would like to bring here is this particular value of log can actually explode if you have very slow values. But this is straightforward. Deriving backprop is just using the chain rule, and then you get the value with respect to your weights. I don't think there are any problems with this particular problem. But let's now look at a slightly different problem. Let's say you have two parallel plates. This is kind of a standard problem in fluid mechanics that you might have come across already. So you have two parallel plates, and then both are stationary. So at both these points you have zero velocity, and then this is a steady flow, like a fully developed flow. So you have some parabolic profile here. The equation is already provided here. U naught is something that will depend on your fluid properties, pressure gradient and other stuff. We do not go into what exactly is it, but it is sufficient if you understand that U follows this particular relation. I want to model this using this. Like I said, instead of using the normal features, I want to use these new inputs, ln of U naught, ln of y, and ln of h as my input features. And I want to use a hidden layer with, say, exponential activation. Instead of sigmoid, tan h, whatever we are using, I want to use an exponential activation. So how does this look like? So what I am saying is, now you have this as my input, ln y naught, U naught, sorry, and ln h as my input. And when I do a linear combination of this, let's say I get something like this is feasible. And for the other one, let's say I have minus 2, and okay, maybe I should use a different color. Maybe it's not visible, but I think you can appreciate what I'm trying to do. And then this should be passed through your activation function. And I'm saying I will be using exponential activation. So what the output here will be U naught y by h. And then I'll use a linear combination again without any bias. So I would directly get the answer. This is what I'm trying to do. First, the architecture should be clear. Are there any questions in the architecture? This is what I'm expecting my neural network finally to get the values to. So can I actually do this? The answer is like very similar to what we discussed previously. You have the same kind of challenges that you have before. Whenever you are using this ln, you have to ensure that whatever you have here shouldn't actually be to 0. So let's say I've normalized this in such a way, plus I've added some epsilon so that this actually doesn't go to infinite. Similarly, I've done even in other layers. Other than that, do you see any other problem here? So here I'm using an exponential activation. Other than that particular problem, saying that it will go to infinite because of these values being 0, do you see any other problem with this approach? Maybe in terms of optimization. Say if I want to, okay, maybe try to answer in terms of an optimization. So if I want to use steepest gradient descent, and say think in terms of backprop. So if I want to do backprop, do you see any problems here? Okay, maybe let's say if I change my activation from exponential to tan h, or let's say I change, this is same as log exponential layer that I discussed just now. It's very similar to this. So all I am doing is first applying a log to my original input. So if I were actually using u0, y and h as my input parameters instead of ln y, u0, ln y and ln h, and then I am just multiplying with some weight vector and then taking an exponential of it. So this is essentially a long exponential layer that I am proposing. So do you see any problem in this? Say if I want to do back prop, so these are the weights that I would be getting. So if this w value is kind of high, then what would happen here? Will anything be wrong? This is between 0 to 1, so this is fine. What the second one will again might explode if x value is very close to 0, so which means your gradients can explode while training. So while doing back prop, your gradients can actually explode and then you might not actually end up with any of these weights. That could happen, but you can actually train a network with this approach. There is no problem in that, as long as you ensure that this epsilon is there so that this ln value doesn't blow up or doesn't go to infinite. You should be able to get to some reasonable answer. So now let's say if I want to change my activation from exponential to tan h, do you think the same architecture will work, or in the sense like this approach will work with the same inputs? So all I am saying is I will replace this exponential with tan h.
No, it doesn't.
Okay, why not? I will change
Because
the
of the
architecture.
range.
Yes, because of the range you will be saying.
Range.
Yeah, this u0 y by h could actually be between different values. So if you use the tan h, your values will be same. Goes with your okay. Tan h is between minus and 1, so you have that problem. So what about ReLU? So instead of tan h, if I use ReLU is between 0 and some finite quantity, and all these values are 0 and some finite quantity. So you should be able to use ReLU and get to the final answer. Okay. Now, say if I want to use a pin for this, how would be my loss function? In addition to loss, I should be using a differential equation. So what will be my differential equation? This is a very straightforward question. So if you are into the fluid problem, you would already know what is the governing equation from which this particular equation is derived. So we will be using that. To those of you who do not know the governing equation, how do you do that? It's more of mathematical than, it's not related to this particular course, but you can just do the derivative of this and then come up with your own differential equation. So you can do du dy and see if this is coming out to be purely function of u, like you should eliminate y from this, and then you do again d square u dy square till whatever limits you have, and then you finally eliminate y from your equation using these particular values. Then you get your differential equation, use that in your pin. So that is a straightforward one, so I don't want to go much into that. Okay, the last question, this is the last question I have, and for this particular question it refers to the problem that is discussed in the lecture videos. So if you have gone through the paper, okay, let me ask, have you gone through the paper or have you gone through the lecture? I assume that you have already gone through the lecture, so you should be able to answer these questions. First is that what in the loss function they have used, did they use any PDE in order to get the particular, like they were actually using different kinds of geometries, and then they finally did some validation with some car. So that is what is shown in the video. So did they use any regularizer? You may not be able to answer this purely based on logic. This is completely based on if you have gone through the paper, it should be straightforward to answer. Otherwise, I am just giving the answer that they have not used any of this. The next is an important one. We have discussed this even before, that CNN, whenever you are using a convolution operation, the convolution operation is not invariant to rotation. or any of this scaling. We discussed this even before. So how did they achieve this particular invariance? So both of these are kind of related to each other. So how did they achieve rotational invariance? I kind of told the answer. If one is not true, then C is not true, so B should be the answer. So the point here that I want to highlight is most of your fluid problems, or in case most of your physics, when you deal with engineering problems, they will be rotational invariant. Convolution operation by default are not rotation invariant, so you have to augment your training data with by actually rotating your images and doing some scaling, zooming and kind of stuff, and then you generate more training data and use them to train your CNN. So instead of having a rotation invariant model, you are doing this explicitly so that some portions of your kernels will actually learn this invariance. So how did they verify the generalizability of the model? In a sense, how did they ensure that their model is not overfitting? How do you in general assume that, or prove that your model is not overfitting? They have not used any regularizer. How do you test it?
So with the training data, if there is no error, then it is overfit.
No, in the training data, if there is no error, and then there should be something else as well. Just from training data, you cannot say, if you have a very good model or a perfect model, even with that model you will have zero training error, right? If your data is good enough, if you have very good data and very good model, you can still have zero training error. There should be something else, right, to say whether you are overfitting or not. What is the second thing that you need?
Bias is less.
Bias. So basically you will compare it actually with your validation or testing data. So instead of just using the training data, you will also use some new data and then use the model on the new data and see if the error is actually low even on the new data. If the error is low on training data and high on your testing data, then you say that your model is overfitting for that particular training data.
No.
Okay.
Maybe we have to fine tune the parameters.
Okay, you fine tune the parameters and got a zero error. So then you can say it is not overfitting.
Actually, yeah, you are right. So first training data,
Yes.
then validation,
Yes.
then you should work on the testing also.
Yes, that is when you actually come to a conclusion whether your model is overfitting or not. Just with training data, you won't be able to tell anything about your overfitting. So in the particular paper they have done, in the particular work that is being shown in the lecture video, they actually tested it on a data set which is completely different from your training data. The training data has shapes of squares, rectangles and so on, so primitive shapes, but the testing data is on completely car is something that is completely different from your small training data. So even on the testing data, it gave you good results, which means that the model is not overfitting on your original data set on which you have trained it. That is how they kind of ensure that their model is not overfitting. So it depends on the data choice you have chosen. You have to essentially get your data in such a way that it is completely different from your training data. By completely different, I mean to say that the problem should be the same, but it's quite tricky to say, like the training data should be representative enough, but your testing should be done on a slightly different way to ensure that your model has not learned, or to say, put it in the terms that they use, they have not memorized your training data. That is the whole point of choosing your testing or validation data for that sake. Validation data is where you fine tune your parameters.
Yes.
Okay, so I think now you agree that the particular model that I have used is for the last option. So they have used a different kind of testing data and they ensure that the model is generalizable. So this is the last part. This is actually not a question kind of one. This is a very old work, 2014. There was actually one question last week. I think that particular person is not in the session today. Maybe he'll watch the recorded lecture. So before actually going into that, do you have any other questions that you want me to discuss? Or any queries?
Sir, you're talking about the papers. Are they available in the website, or we have to go to the? Are they available in our?
These are not part of. This is not part
site,
of the
or
course.
We have to go.
No, this is not part of the course.
No, not this, sir. Not this. Not this. Sir told one paper.
That is available on Google. You can directly Google and get it.
Okay, directly Google. Okay.
Yeah, it's available on archive, so you'll be able to get it. But as far your exams are concerned, the questions will be similar to what your assignments are there in the weekly assignments that you are solving. It will be very similar to your weekly assignments, like the same level as your weekly assignments.
Sir, only
MCQ type.
MCQ and MSQ only.
There will be only
no essay questions, sir.
No, nothing. All are MCQ questions. Same like your weekly assignments.
Oh, excellent.
I think it was discussed before that it so happens that 50% of your final questions will actually be exactly same as your assignment questions. Approximately 50%.
No, we don't know that.
Sir, actually, what is the passing percentage, sir? Do you have any idea?
No, I have no idea on that.
I think around 50%, sir.
Sir, it is 40, sir.
I am not aware of that. You can look up in the website.
40.
No. 40 is very high percentage.
Sir, considering both, sir, assignment as well as final.
Yeah. No. What I am saying is, you have to get only 40%. 40% I don't think that it is very difficult.
Okay.
Individually also, sir. Assignment individually and exam.
I think I already classed that.
Let's leave that part aside. No, let's leave that part aside. Other than that exam queries, do you have any other technical queries that you have that we can discuss before actually going to the last part? Because this is something that is not part of your assignments for this week. So if you don't have anything else, then we will actually go into that, because the person who asked this question is also not available today.
Sir, I have a general question, sir, like application wise.
Okay.
Related to regression model, sir.
Mm-hmm.
Can I ask that, sir? Regression model?
Yeah, sure.
Yeah. So actually I have data like some navigation data, sir, from one point to other, from x1 point to x2. So if I want to predict that navigation path, so can I use the regression tree model, whether it is possible?
See, as it just to give in a general way, I do not know exactly the problem you are trying to solve, but in general, model is just a model.
Okay.
You cannot say if it works or not unless you try it out.
Okay.
Without actual details, I cannot be able to say whether it is a good or a bad model.
No, you are saying, sir, I am sorry to interrupt.
Yeah, sure.
You are saying that you have a navigation data, right?
Yes, sir.
So, and in that navigation data, do you have some what we call gaps, or is it a continuous one?
Continuous data.
And what is that here? Then what is that you are trying to predict? It's already there.
No, for training I am using continuous data. For testing, I'll choose the data with gaps. So it has to predict gaps.
Okay. So no, don't think otherwise. But my point is that you have data from A to B, or X1 to X2.
Yes.
And it knows that path. So it, I don't know what is the.
Basically, what he's trying to ask you is why do you need a model?
No. If you have dots, sir, if you have dots also, you can connect them without any model.
Yeah. Okay. I got your point. So what he's trying to ask you is if you already know the path, what is it that you want your machine learning model to do, or what is it that you want your regression model to do?
Okay, sir. Actually, until like if I'll train the data, sir. Actual path, I will train the data. If at all any like in future, if I want to test some other by using other data which has some gaps,
Okay.
so then can we use like regression model? That is a
Okay. So whatever training data you have, whatever testing you are expecting in future is completely different from your training data, and you still want to use the same thing.
yes, yes, sir.
Okay. Yeah, I cannot directly comment whether which regression model will work or not, but you can just give it a try. It's not a big deal.
Okay,
But all models are just models.
okay, okay.
If you have any specific, like if you already tried to implement some model and then you have some query, then maybe I could be able to address it directly. But this is a very generic question, so I cannot comment anything.
Sir, actually, what I did is like I've taken some navigation data like latitude, longitude, and altitude from one point to other using a smartphone, sir.
Okay.
We will be getting latitude, longitude, and altitude, and I have checked it by like giving to the regression algorithm, like regression tree. I have used regression tree, and how well it is giving the MSC values, how well it is modeling
So
uh,
basically your inputs
these
are,
values. I have checked it.
so your
Inputs
inputs
are
are
latitude,
latitude.
longitude, and altitude.
So what is the output?
Latitude, longitude, altitude.
So what is your output?
Okay. These should be the output, sir. Latitude, longitude, and altitude should be the output.
Okay, then what is your input?
Input is time with respect to time.
Okay, so you just want latitude as a function of time, longitude as a function of time, and altitude as a function of time. That's it.
Yes, yes,
So it's some person traveling or something, and then you just want it as a pure function of time.
yes, sir.
Okay. See, I can tell you directly that if this function exists in the first place, then your regression tree should be able to fit it. But the question is, does this exist in the first place? If your count truth is correct, then it should be fine.
Sir, I wonder actually how time only the input and you can give
Yeah,
latitude and that's not possible, sir.
no, let him try it. Like he should try it and then see. We cannot comment. So maybe it so happens that if you have x of t something like this and y of t something like this, and it so happens it happens in your projectile. There u is something like, as long as you have the same projectile with same velocity and same gravitational acceleration, then your position could be directly written purely a function of time. It could happen, it cannot happen, but most likely you will end up with having an overfitting model if you end up.
Okay. Sir, actually, I have tried this using like in MATLAB, we will be having regression learners, sir.
Yes.
So using that, I have tried this.
Okay.
Uh,
And then
so
you
in that,
tested on what?
I have
So how did you prepare your training data and testing data?
test training data is the collected data, sir. That from one path to the other, one point to the other point, and I'll be training for like 2 to 3 days. I'll be taking the data for in the same path,
So it's for the same user, or you have
and for
different
testing
users?
is different users.
So each user can have different speeds and everything, right? So I don't know what navigation data you are
Yes,
collecting.
yes, yes.
So you are not incorporating any of that into your model.
So I just initially I'm trying like regarding like only latitude, longitude, and altitude, and speeds I'm not considering as of now. Like
Okay, but how will your model know that there are different users? Because depending on the user speed and things like that, the function of this with respect to time will change, right? How will your model know that without actually giving any
okay,
input?
okay,
That is what I think he was trying to mention. Like just with time, you will not be able
okay,
to completely get a proper model. You need to come up with
okay,
more
okay,
features.
okay. Okay, like features like sir, any any inputs regarding this, sir?
Yeah, so basically from whatever you have in your domain, so in order to get these exact positions of that particular user, what are the things that you will be needing? The type of vehicle, the type of road he's going on, the velocity with which he's going, all these are the factors that need to be known. But do you have all the data in your training?
Okay.
I don't think you might be having all the data.
No, as of now, I
You just
don't.
have time.
Yeah, as of now it is
Okay,
not.
so you just have a time
Yes.
series and you want to forecast it.
Yes.
Is it that something that you are trying to do instead of regression? So basically you have latitude,
Yes.
longitude. So you
Yes.
have time, you have latitude varying something like this, longitude varying something
Yes.
like this. So you
Yes.
have up to.
Yes. Yes.
So okay,
Yeah.
that is a different problem. So you are essentially want to do some time
Okay.
series forecasting.
Yeah.
This falls in the RNNs, right? You can use RNNs. Still, it's a regression problem, but
Okay.
that's slightly different.
Okay.
Does it have any periodicity in it?
Okay. Okay.
So
No,
basically,
sir. Initially, I'm testing only by taking time, sir. As of now, I
I'm
haven't
just
gone to,
giving
and
an example.
some
So if you are
features
just
like,
taking time, if you are just considering time, you can
yeah.
treat this as a time series. So that's when you have RNNs, like things like LSTM come into picture. So you take the
Okay.
history of the
Okay.
data,
Okay.
and from the history it will actually generate its own features, and then it will be able to forecast what happens in the next time frame. That could be one way
Okay.
ahead
Okay.
if you just
Okay.
have time. But if you have other features,
Okay.
then it's better to use them.
Okay. And other features that can be considered are like signal to noise ratio, C by naught, and another one is elevation angle are there. So those features can also be considered, which affects the position of the user, right?
How does signal to noise
So
ratio affect
I'm
the
trying in
position of
that
the
way, sir.
user? Okay. Yeah, it's up. As long as you know that there is a connection
Yes.
between whatever your input and output is there, then you should use that in your feature.
Okay.
That's the only general comment I can give you.
Okay. 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 Sir. Thank you. Thank you, sir, for the inputs.
There are no further questions. This is nothing related to your course, so if you have something, feel free to leave. I just want to discuss this because one person asked in the last class. So this deals with something called a surrogate model. So the problem here is you have, say you have an aircraft cabin here and you want to design an air conditioning system for this particular cabin. So the design variables are essentially you need to choose where to keep your inlet and outlet, and then you need to decide what should be the velocity, temperature, and the angle at which you have to throw your inlet air into this particular cabin. And the objective of whatever optimization you want to do is to essentially have a comfortable environment for the passengers inside. So you have to kind of it's like in the beginning of the course we have started with this saying whatever you do you have to quantify it, you need to come up with some number. So these are some numbers. To those of you who are not in this field, and just assume that PMV and DR are some numbers that will tell you whether that particular person is comfortable or not. If these values lie within certain range, then that person is comfortable in that particular environment. But in order to get the value of this PMV, and DR is essentially draft risk and air age and things like this, you need to know what is the velocity and temperature everywhere inside the cabin. In order to get the velocity temperature everywhere inside the cabin, I need to do a full scale CFD simulation. So if you want to do an optimization problem like this, how would you start doing this? You follow something like this. You start with some design variables, you start with an initial guess, and then you pass them with as your boundary functions, like you discretize this domain with some mesh, and then you change your boundary conditions, and then for each of these you calculate the design objectives that you have, and then you see whether you are satisfying certain criteria. If not, you actually update your design values. You keep doing this till you reach your whatever objectives you have set in the initial case. The only problem with this approach is if you are using a tool like say Fluent or OpenFOAM, depending on your mesh size, this can actually be it can actually take say from an hour to sometimes it can even take days, depending on the problem of whatever problem you are trying to solve. This can actually take much longer time. So originally, even without this, the optimization itself is time consuming, and then when you have things like this will be the bottleneck, and you will not be able to get a good design in your real time, or not even in real time, but when you want to design this system, you want these results to be within a day or so, but the simulation will take a month together, and then that is a long amount of time which will not be useful to you. So what people or this particular author has done is to use a surrogate model. So the idea there is you create one database first. So you essentially take some of these design variables, some possible parameters, create a database, and then train a neural network on the training on that particular training data, so that when you give the design variables as input to the surrogate model, it will directly give you the design objectives. So if you tell what is the inlet velocity, angle, temperature, position, and outlet position, it will directly give me these values. So it is a kind of regression model that will map between this and this. So once it does that mapping, you will use that particular surrogate model to see whether to get the design objectives and see whether the design objectives are within the range that you want. Say for PMV, if it is between say minus 0.5 to 0.5 is what you want, and you see if this ANN model is predicting in that particular value, then what they can do is instead of using the CFD tool, they will replace this with a surrogate model. The problem with that approach is if you completely replace this CFD tool with a surrogate model, how will you ensure that the surrogate model is accurate enough? So they kind of did one more step further. So whatever outputs they kind of found reasonable enough, they again did the simulation with the CFD tool to kind of reassure that the output of surrogate model is good enough. And then once they have the accurate objective functions, they will kind of see whether it converges or not, and they keep repeating this. So using this approach, the main thing is the bottleneck previously was at the CFD tool. Say if this is taking an hour or say 2 hours for one simulation, the surrogate model will give you a result in say minutes or say even seconds. So that way you will be able to kind of reduce the total simulation or the total time for your optimization problem. This is one approach where you can use your surrogate models. These are some details pertaining to that particular surrogate model, but the questions that are important for us when you come across works like this, or first is that most of these models are used only for interpolation, or even for the example that you have stated, you need to ensure that this model is used only for interpolation and not for extrapolation. This is true in most of the domains. So how do you ensure that you are doing this interpolation properly? So you have to ensure that your training data is representative enough. By representative enough, it means that it should be able to capture all possible scenarios that you are likely to encounter in the area where you want to use your ML model. It should not be exactly same, but it should cover. So let's say if you have on a 1D example, so if you have a function like this, your training data should at least sample at good enough points, or let's say a slightly different one. Say if this is your function that you want to fit with your regression model, and if all your training data is just doing in this particular region, but instead of covering this entire region, if your training data is just sampled in this particular region, then the model is likely going to be not work when you actually give your training data, when you actually test it on something like this. So when you are doing, or when you are kind of making your training data, you need to ensure that it will cover all the possible representative samples that are possible for the real life application of that particular model. So basically you need to have the entire range that is being covered by the training data. The other way is you add a regularizer. Maybe I'll discuss that tomorrow. So actually train one pin and see that instead of giving the entire range, you can actually reduce the range and kind of add the regularizers so that it will actually know the function in a slightly different way. But as long as your training data is representative enough and your model is complex enough, it should work. This is something that we already discussed before. So how do you ensure that is not overfitting is that you need to give a testing data set, like your training and testing data sets should be different, and then once you compare the errors of these two, and then you will see if they are both are less, then you say that your model is not overfitting. The last one is how much accuracy do you want for your surrogate model. Here the surrogate model in this particular work, the aim of the surrogate model is only to guide your optimization algorithm. It's not to essentially do some, like essentially get what is the accurate value of PMV that is required or not. The only aim of this model is to ensure that your optimization algorithm is going in the right direction. It's like saying in your gradient descent, in each iteration step, what you want to do is ideally you should be using the accurate terms, but you have just replaced everything with a learning parameter times your gradient. So all it does, it tells you is that you go in this particular direction. By how much is something that we actually decide through a hyperparameter. In a same way, this surrogate model will only give you the right direction for your optimization algorithm. So in order to give the right direction, you need not be very accurate. Even a lower accuracy can actually be useful sometimes. So these are very subjective kind of things, and I cannot give you a concrete idea on how to do that, but in different works you will be actually seeing that most of the people will try to address these problems in one way or the other. So they'll actually use a surrogate model with a lower accuracy instead of a higher instead of the original one. But at the same time, they'll ensure that even with this low accuracy, it performs the job that is intended to do. Second, in order to prevent overfitting, they have to come up with some strategy that will differentiate my training and testing data in some way or the other. And the first point is something that I want to give a little stress over. So how do I generate my training data? Let's say in this particular case, I have these 5 variables: velocity, temperature. Say alpha is the angle at which you are throwing air inside. P in is the position of inlet, and P out is the position of the outlet. And let's say I have each one of them coming from a uniform distribution of different values. Say U is coming from a uniform distribution of say 0.1 to 0.5 meter per second. 0.5 is also too high. Let's say 0.01 to 0.15 meter per second. And temperature is coming from say 10 to 15 or 16 Celsius. Angle, like each one of them has a different range, and all of them are equally probable. Initially all of them are equally probable, so I'll assume they are coming from a uniform distribution. So now how will I generate my training data? I'll give you one approach, then maybe you can comment on is there any problem with that particular approach. Let's say I just take a random sample. U is coming from a uniform distribution. U is a velocity coming from a uniform distribution of say 0.01 to let's say 0.2 meter per second. So if this is the range, similarly T will have some range, alpha will have some range, P in and P out will have some ranges. So what I could do is pick a random sample from this one, let's say U1, pick a random sample from this one. I'll just write one. Randomly pick one sample from each one of this, make one pair. Similarly, I can again sample randomly the second sample and keep on doing till I have whatever batch size I have. Let's say I'm using a batch size of 128. I'll generate 128 samples in this way. Do you see any problem with this kind of sampling, or is this okay? It's like I'm just doing a random sampling. So will this be fine, or is there any issue with this?
I think data is homogeneous.
Data is homogeneous. Maybe you can elaborate a little. So what happens if data is homogeneous? So is it good or bad? Data came from the same parent distribution. Yeah, initially I don't know anything about what these values are. So my initial best case would be assume that everything is equally probable. So I've assumed it is a uniform distribution. If I would have known that some particular values are more probable than others, then I will actually choose a different distribution for each one of them. But let's say I do not know anything about it. So I'll assume uniform distribution for each one of them. Okay, let me put it in this way. So this kind of data that is generated, will it be representative enough of the entire population? Or maybe let's say even simpler. So whenever I am generating this one, am I doing it with replacement or without replacement? So if you are recollect from your probability, so you have two kinds of things. So whenever you are sampling from some, say if you are taking some ball from some bag of balls or something, you can either do with replacement or without replacement. So when I am sampling from a uniform distribution, what is it that I am doing, with or without replacement? or maybe let's put it simply, even, okay, let me ask slightly differently. So let's say you have some function in MATLAB, say randoff or something, that will give you a random variable with within some distribution. So if I use randoff, so what is it doing? Is it giving me with replacement or without replacement? I cannot directly use with or without replacement because it is a continuous distribution, but I think you got the question that I am trying to ask.
Yeah, I got, sir. I think you're asking the numbers are repeatable and repeating are
Yeah.
non-repeatable.
Yes. So when I
Like,
do this
when
kind
you
of
generate
sampling,
the data,
yes.
yeah, it should be uniform as well as repetition should be less.
Yes. So the point here is you need to ensure that whatever sampling method you use, that will actually reduce the repetition or let's say redundancy or something like that. So when I do this kind of sampling, you'll have the uniformity, but then mostly this is done with replacement. So there could be redundant samples when you generate large enough data set. Maybe for 128 samples it may not be clear, but when you generate so many samples, you will find that most of the data is redundant and kind of repetitive, which means that your model is kind of seeing the same kind of data again and again, so which is not always good enough. So even when you generate this training data, you need to come up with some strategies that will ensure that whatever training data you are using is kind of diverse enough so that the model will see all possible scenarios. So one way people have done is something called Latin hypercube sampling. There are several sampling methods. I'm just giving you one example. It's the simplest one. So what I do here is first I generate, say if I want to generate 128 samples, I'll generate 128 samples from U, and then I generate 128 samples from T, the same way as before. But instead of repeating again and again, I'll ensure that whatever I have already got, I'll remove, let's say, let me put it simply. So here what I have done, instead of doing it in horizontal way, I'll do it in a vertical way. So I'll generate 1 to 128 samples directly at once, and all 128 again. I'll do this in this way, and then I'll do the mapping separately. It is observed empirically that this particular way of sampling will ensure that your redundancy is reduced when you have a very large training data set. For small training data set, even this is very similar to whatever you do with the one that I have chosen here. I do not have any proof for that, but you can take my word. I can just say that you can take my word for it that for very large samples it actually works better than the random sampling. But the point that I want you to understand here is how you generate training and testing data is also important. That's the whole point or the takeaway from this particular question that I want to choose here. Yeah, these are the questions I have for today. So if you have any other questions, I'll leave the last 30 minutes for discussion. If you have any other questions, we can discuss them. Otherwise, you can feel free to.
Sir,
Okay.
can we have one more session before the exam?
Actually, we have a session. The last session ends on 18th. We are not allowed to conduct sessions after 18th. So maybe we can have one session tomorrow.
So, tomorrow, yeah, Sunday. Excellent, sir.
Tomorrow we can have one more
Evening.
session. Yeah, evening, same time, 5 to 7.
Sir, if you don't mind, just I don't know how you take it. Can you tell something about yourself, sir?
Yeah, I am a PhD student working in IIT Madras. My research area is slightly different from this. So I am working on something related to building ventilation, not aircraft cabin, but it essentially deals with how you essentially design your ventilation systems using ML models.
Okay. So you're from mechanical department.
Yes, I am from mechanical department. So I am a second year PhD scholar.
Excellent, sir. Okay. So that PhD is done through GATE, sir?
I'm actually a direct PhD student. So
Okay.
I completed my BTech and then I entered PhD, not through GATE.
Oh, okay. Fantastic, sir. Thank you very much.
Okay, then we'll have one more session tomorrow at the same time. I'll ask the NPTEL team to actually send an email. If you have any questions, then maybe you can ask the questions tomorrow. In addition to that, I'll also be discussing a few other papers because there was some request before on some coding related to pins. So I'll cover one aspect on, like, actually show you some demo code for a pin, because there was one question previously on that, and there was a question on GANs as well. So maybe we'll go through one paper on GAN and one on variational autoencoders, in addition to any other questions that you have. Yeah, hi. Yeah, these are the questions I have from my end for today. So we'll meet tomorrow. So if you have any other questions, we can discuss them. Yeah, if you do not have any questions, feel free to leave the session. I do not have anything new to add right now. Okay, so what I was trying to say is, if you have multiple dimensions, yeah, okay, one second, we'll answer this question first. So if you have a multi-dimension, say something like this, you can actually generate, to put it simply, say you have two dimension, x1 and x2, both are uniform distribution. One way to get a sample from this is take this entire domain and randomly pick points from this. This is what is called a normal random sampling. What Latin hypercube sampling does is, it will generate first samples from x1. Say if you want to generate n samples using this is say RS, random sampling method, you first create this, and from this 2D domain you pick n points randomly. This is one way. What Latin cube does is, first it will consider only x1, generate n samples, then it will only consider x2 and generate n samples, and with this it will pair, like you have an x1 and an x2, so you create randomly, just select one x1 from this, one x2 from this, again second, third, so on. So what you ensure here is, each of these samples can actually be diverse enough instead of the previous one. In previously, once you generated the first sample, then when you are generating the second sample, you are not sure whether it will actually get repeated or not. But now that you already know out of these n samples, when you generate the second sample, you will be using only n minus 1 instead of n. When you generate the third sample, you will use the remaining n minus 2 samples. So this way will ensure that your or your redundancy is actually reduced. So is that clear? The takeaway is this: you want to do it without replacement. Latin hypercube sampling does it without replacement, while the previous one does it with replacement. That's the crux of it. Yeah, there was another question. So someone raised a hand previously. I guess if there are no questions, any reference book you suggest for further learning? Okay. By further learning, in the sense, you want to like, each topic itself is a bigger area. So I do not have any reference books that I can suggest you. It's like if you want to work in GANs, there are books only on GANs. If you want to work only on autoencoders, there are books on autoencoders. So, but whichever it is, you get started with whatever you want. You'll eventually get to the right one.
Sir, can you show like any demo code related to RN and LSTM, sir?
Okay, maybe tomorrow. I do not have anything as of now.
Like in MATLAB, using MATLAB.
Okay. I actually have not done in MATLAB. I have done in TensorFlow. I think that shouldn't be a problem, right? Whichever language they teach. The point is you appreciate how it is done.
Okay. So actually in MATLAB we will be having directly an user interface is there. So in some of the lectures it has been
Yeah,
shown
MATLAB is
using
what.
that user interface itself.
Yeah, lecture videos MATLAB is what is followed.
Yes, yes.
No, but the
So
only
just I
thing
wanted
is
to explore that, explore using MATLAB.
okay. Yeah, I do not have anything as of now. Maybe tomorrow I'll try to see if I can get it.
Sure, 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 sure.
Any other queries? Okay, I'll keep the forum open for discussion. We have around 20 minutes left. So if you have anything, you can ask. Otherwise, you can feel free to leave the session. Thank you. Okay, maybe just to initiate some discussion, maybe I can ask a few questions. But if you are occupied, then maybe you can leave the session. Okay. Yeah, I guess there are no questions. Then we'll meet tomorrow at the same time. Thanks for joining. We'll conclude the session for today.